Hello, students. We're going to go through the PowerPoints. This is in case you missed the Zoom lectures that we had. We're talking about chemistry. We're really looking at what are things made of, how are they put together, and what characteristics they have. So chemistry happens in everyday life. When food is cooked, when a car battery is started, when you have an upset stomach and you take an antacid tablet. So it's very important to understand why you're taking this class, because a lot of you are allied health majors and you're going to need a lot of the material that we cover for future biology courses. So the first thing that we'll go through is scientific method. Right now during the COVID crisis that we're actually seeing a lot of scientific method take place. So let's go through the features of scientific method. First is there's an observation that's happened, there's a question that's asked, and then someone gives an educated guess or statement that explains that observation. And then experiments are performed to test that hypothesis. And then after all that data is presented, there's a theory or explanation that explains all those experimental results. Okay, so scientific method then is observations, some question is posed, hypothesis, experiments, and then theory. I think the problem with real life right now is that there's a tendency to talk about a hypothesis as a theory. So somebody's just putting out an educated guess that hasn't been tested and people think it has been. So there's a lot of discussion right now regarding COVID, different things about it, like, for example, why, maybe a good question would be, why is it spreading differently among younger children as opposed to adults? And so then scientists come up with an explanation, educated guess to explain that. That's a hypothesis. But here's the thing is that you can't just say what you think. You have to test it out with experiments, and experiments have to have a lot of data, not just one set of data points. And then from all that data comes the theory or an explanation of what is happening with that data. So in other words, like a conclusion, an analysis of the data, and an explanation. So a lot of times the experiments don't match the educated guess on what's happening. So they have to be refined and changed. Okay. All right. So here's our first learning check. What is the following? Is it an observation, hypothesis, experiment, or theory? So take a moment to do those. You can pause me. Okay, so a blender does not work when plugged in. That is an observation, right? You're just saying an observation. The blender motor is broken is an educated guess, right, as to what's going on. That's a hypothesis. Another educated guess would be that the plug has malfunctioned. So that's a hypothesis. Then you can carry out an experiment. The blender does not work when plugged into a different outlet. That's our experimentation. And then once all of that is pulled together, all that data, which isn't a lot in this example, then you come to the theory that the blender needs repair. Okay, so I think right now what's really important is to not think that an educated guess has been tested out. You have to have data, you have to have a lot of data, and then scientists have to review the data, make sure that the way it was collected was appropriate and done correctly. And that's what right now you're hearing a lot about peer-reviewed data. That's been through a lot of scientists looking at that data and double checking the theories that come out of it. Why is math important for your major, for allied health students? Very important to be able to do dosages for medications based on somebody's weight. For nutritionists, understanding calories and fats and carbohydrates and what is energy, very important. Okay, just a quick review. If we have a number like 4,378, the 4 is in the thousands place, the 3 is in the hundreds, the 7 is in the tens place, and the 8 is in the ones place. And this is going to be important for us as we learn how to take measurements. Okay, and then with decimal point, the 8 is the ones place, the 1 is the tenths place. See the tenths here. Okay, the 9 is in the hundreds place, and the 2 is in the thousands. Okay, so take a few moments. You can pause me and do this question, and then you can see the solution on the next slide. Okay, when we're looking at positive and negative numbers, a positive number is a number that is greater than 0. So usually the positive sign isn't shown. So if I have the number 8, that would be assumed to be a positive 8. A negative number has the negative sign in front, and that's a number that's less than 0. So just a quick math review. If we have two positives, that's easy. 3 times 4 is 12. But negative 3 times negative 4 is also 12. So remember the rule for multiplying negative numbers there. 3 times negative 4 is a negative 12. Negative 3 times 4 is also negative 12. So a positive number and a negative number multiplied, the answer is negative. Same rules for division. 8 divided by 4 is 2. Negative 8 divided by negative 4 is also 2. Okay, so addition with positive and negative numbers. 2 plus 3 is 5. Negative 2 plus negative 3, you're getting more negative, so that goes to negative 5. And then if you have 11 plus a negative 15, that's like subtracting 15 from 11, so you get a negative 4. Okay, so here's some practice, and make sure that you go back through these more slowly. You can pause me and just practice them. Okay, percentages are very important in chemistry. What we're going to see here is that you have a part per whole. So let's say you have 5 pennies out of 20 that 20 coins. So what percent are pennies? So 5 out of 20 times 100 gives us 25% pennies. Okay, and in chemistry, we're going to talk a lot about percentages later. So I think this is a really important review. Okay, if you have, let's say you're eating 2 pieces of pizza that contain 6 pieces, what percent did you eat? So that would be 2 out of 6. 2 divided by 6 times 100. So that would be 33% of the pizza. Okay, so 25% can be converted to a decimal. So you'd say 25 divided by 100. And then if you actually plug that into your calculator, you'll get 0.25. But another way of thinking of it is that you can take the value and move the decimal place over. Okay. Okay, so solving equations is really important for our class. So if you have an equation algebraically, that's 2x plus 8 equals 14. If we want to solve for x, our first step will be to subtract 8 from both sides. And in this case, then, if you look on the left side, 8 minus 8 is 0, so that gets taken out. Then 14 minus 8 is 6. So we're left with 2x equals 6. And then to isolate x by itself, you would divide both sides by 2. And 6 divided by 2, x equals 3. And if you want to double check your answer, you plug in. So 2 times 3 is 6, plus 8 is 14. Okay, so take a moment and try to do this where you have temperature Fahrenheit is equal to 1.8 temperature Celsius plus 32. Take a moment to do that and then solve for temperature Celsius. So take a moment, you can pause me. So our first step would be to subtract 32 from both sides. And when you do that, you end up with temperature Fahrenheit minus 32 equals 1.8 temperature Celsius. And then to isolate temperature Celsius, you would divide both sides by 1.8. So our ultimate equation, temperature Celsius will equal temperature Fahrenheit minus 32 divided by 1.8. Okay, take a moment to solve for R and PV equals nRT. So if we want to get R by itself, we want to get rid of the N and the T. So what we would do is we would divide both sides by NT. So if I divide both sides by NT, R will equal PV over NT. This is going to be a famous equation in chemistry called the ideal gas law. And so it's an important one for you guys, but we'll come back to it in later sections. Okay, so that was the lecture for last week, Tuesday. I told the class at that point that we were going to do the line information when we got to the section on gas laws, so don't worry about that at this point. So for this video lecture, I'm going to stop here.